Today I am solving the problem of the Mohr circle of question number 4, where a overhang crank is fitted on the wall and the load is applied apart from a distance from 250 millimeter, which is parallel to the z axis and y axis, and load 1 kgp is applied from the xy axis to 500 millimeter distance. This is 1 kilonewton. This 1 kilonewton is first applicable to overhang crank tend to rotate due to torsion. This is the first torsion moment is carried out here, and if load is shifted at B, then it will be tend to bend the overhang crank. Now here two stresses are developed. This is the shear stresses and bending stresses. Now first we calculate the shear stresses, which is in step 1. Here shaft is subjected to the load at a distance 500 from the x-axis. Then P equal to 1 kilonewton. Therefore 1 into 10 to the power cube Newton. Load apart from the bracket will YZ. This is 250 Newton, which is said earlier. Shaft is made of the plain carbon steel. 40 C8, which yield strength is 380 Newton per millimeter square, and given factor of safety is 2. Then tensile strength we can find out by the SYT divided by 190 Newton per millimeter square, and here ultimate shear stress we can find out by the SSY equal to 0.5 SYT. Here SYT is written. By mistake I am filling the here value is SSY equal to 0.5 SSY, but it is the corrected value is 0.5 SYT. SYT is the yield strength. Therefore this value is 190 Newton per millimeter square. Now allowable shear stress we can find out, divide SSY divide factor of safety, then 190 divided 2 is equal to 95 Newton per millimeter square. Step 2, by the load P of radius 500 millimeter, then couple will make the torsion moment in MT equal to P into R, then 1 into 10 to the power cube into 500 millimeter. Therefore 5 into 10 to the power 5 Newton millimeter. We find the torque moment, and therefore shear stress is, we know that the shear tau equal to 16 MT divided pi d cube, which is the formula is M by I, MT by I, P, and Fs by R applicable here, and then value is 16 MT divided pi d cube. And now the tau is, we find the tau which is shear the our overhang crankshaft. This value is 2.546 10 to the power 6 divide dq Newton per millimeter square. Again we step 3, finding the bending moment sigma b. Then P load is at B, then the couple will make the bending moment MB equal to 25 into 10 to the power 4 Newton millimeter. We apply the bending stress equation, sigma b is equal to MB into Y by I. Then we put the values, and we got the bending stress 2.546 10 to the power 6 Newton per millimeter, 10 to the 6 divide d cube Newton per millimeter square. And also first earlier we get the result and find out the result of tau xz and tau zx is a 2.546 10 to the power 6 divide 10 to d cube Newton per millimeter square. And the both value is 2.546 10 to in multiply 10 to the power 6 divide d cube Newton per millimeter square. Here the stresses as point A, at point A, where the tensile stresses sigma x is in tensile but sigma y is in 0. Therefore tensile stress sigma x due to x direction, which is the sigma x, is in tensile nature, and it will be bending stress equal to bending stress, and sigma y is in 0. Here no stresses is. Applying the maximum shear stress theory, tau equal to sigma x minus sigma y by 2 whole square into tau xz or tau whole square. Then sigma y is neglected 0. Then putting the sigma x value is equal to the sigma b, and now the value is in under root under 2.546 10 to the power 6 divide 2 d cube whole square plus 2.546 10 to the 6 divide d cube whole square. Now the result at tau maximum is 2.847 10 to the power 6 divide d cube Newton per millimeter square, which is equal to the level shear stress we will find earlier. We also find the values from the tau level in this question when starting moment of the solving the question. From step 4, finding out the diameter of the overhang shaft, which is d equal to what? It is in millimeter. Therefore tau level we have earlier calculated, which is 95 Newton per millimeter square, which is equal to the tau maximum 2.847 into 10 to the power 6 divide d cube. Therefore we put the value of 95 and equal to right values, and then d cube equal to 2.847 10 to the power 6 divide 95. Under the cube root, the value d is the diameter of the overhang shaft is 31.6 millimeter, and for the safety consideration we can take d equal to 32 millimeter. Due to this diameter will sustain the load of 1 kilonewton as per drawing. If my calculation is like, then you will subscribe my channel and thank you for watching my videos.